So this lesson is about standard deviation and variance. And standard deviation and variance are two different, well, they're actually the same measure expressed in two different ways, but we're still talking about measures of spread. So we've talked about measures of central tendency that told us where the middle was of our distribution, and we're still looking at ways that we can measure how spread out or how clustered our data are to this middle value, either the mean or the median. And standard deviation is the most frequently used measure of spread, and it's probably the most important one. And if you go on and take any more statistics courses, you are going to see standard deviation over and over and over again. So what you want to be able to do by the end of this lesson is calculate the standard deviation and variance for a set of either raw data or group data we've been working with. And more importantly, you probably want to use the standard deviation to interpret a set of data, or most importantly, compare two data sets to one another. Because usually the standard deviation doesn't tell you a lot of information on its own. It's most useful when you're comparing two sets or an individual value to the rest of the data in a set. So let's take a look at what standard deviation is. As I've said, it's the most common measure of spread. The symbol is the Greek letter sigma, so that O with a little tail on it. A large value of the standard deviation indicates that the data is spread out away from the mean, and a low value of sigma indicates that the data are clustered close to the mean. Now, how do you calculate standard deviation? Well, this is the formula right here, okay? That appears on your formula sheet. Now, we'll talk in just a second about how this formula actually works, and we'll get some practice working with it, which should help you understand what it means a little bit. Before we do that, though, the variance is just the standard deviation squared. So the formula is the exact same formula, just we have squared both sides of it. And the symbol is just sigma squared. So the standard deviation and the variance, they're both telling you the same information. Okay? Just one of them you've taken the square root of it, and the other one you have not taken the square root of it. So let's take a closer look at these two formulas to figure out what exactly is going on when you calculate the standard deviation. First thing we're going to look at here is this thing right here, x bar. What does the x with the bar over it represent statistically? That is the mean. So that is your average. Okay? And these xi's here are all of your individual data points. So what you are doing inside these brackets here is you're taking each value that you have and you are subtracting the mean from it. So basically you're calculating how far away this individual data point is from the average. So when we do this, xi minus x bar, or an individual data minus the mean, this is called the deviation for that particular data point. Okay? So it's how much that value deviates from the average of all of the data points. Now, what do we do with all of these deviations once we have calculated them? Okay? Well, this funny Greek letter sigma here, remember, tells us that what we are doing is we are adding up all of the deviations. Okay? This is a sum going from I equals 1 up to n, and n is the number of data points that we have. So I'll just add that up here. N is the number of data points. Write that a little bit more clearly. Okay. So up in the numerator, we are taking the sum of all of the deviations. And then in the denominator, we're dividing by the number of data points. So if we take a bunch of things, we add them all up, and then divide by the number of things that we have, we are basically taking the average. So we are taking the average of all of our deviations. Divide by number. Basically, this means we are taking the average. Okay. Now, there's one operation that we've done in here that I haven't talked about, and that is this squared here. Our deviations can either be positive or negative. If our value is below the mean, okay, then when I subtract the mean off, I'll get a negative number. If our data point is greater than the mean and I subtract off the mean, I get a positive number. So if we just added up a bunch of positive and negative numbers, they would cancel out and they would give us 0 every time. This is kind of the way that the deviation works. The sum of your deviations is always going to be 0 because some of them are positive and negative. To avoid just getting 0 every time we do this calculation, we square each one of the deviations to make it always a positive number. So I'm just going to say square to make deviations positive. Well, okay. Now, if we've squared everything, when we've added it up, if we want to sort of undo that squaring, we take the square root after we're done everything. So that's why we have the square root in our standard deviation formula. So this is like undoing the squaring. So what the standard deviation represents is it's kind of like you're calculating the average deviation, but you're not calculating the average deviation because of the squaring and the unsquaring. So what the standard deviation is it's kind of like a typical amount that each of your data points is going to deviate from the mean. So it's sort of a standard value for how far away from the mean all of your data points are. Okay? So it's kind of like a mean or a median for the deviations. Does that make sense? Kind of. Okay? So let's take a look at an example where you're going to use the standard deviation. For a game of basketball, a group of friends split into 2 teams. Their heights are shown in the table below. They are apparently organized enough that they gave names to their teams, which usually doesn't happen in a standard game of basketball, pickup basketball, but whatever. We want to compare the heights of the 2 teams, and we want to figure out, does one team have a height advantage over the other? So we are going to calculate 2 things for each of these 2 teams. We are going to calculate the mean, and we are going to calculate the standard deviation. Before we do that, though, if we just look at the values of height that we have in the table, how would you compare those height values? Is there anything that leaps out at you just looking at the numbers? Kale? Yeah. So the Falcons seem to have more variety, let's say. In their heights. Okay, the Ravens are all in the 60s, the Falcons are much higher and lower. Okay, so we're going to compute, for these 2 teams, we are going to compute the mean and the standard deviation. So we don't have to do this twice, we'll just say that for the Ravens, the mean height is 165 centimeters. The standard deviation of those heights is 2.1 centimeters. So each height varies from 1.65 by, on average, about 2.1 centimeters. We want to calculate those same 2 values for the Falcons and then compare them. If you're doing this calculation by hand, it's good to organize things in a table. Okay? So we've got our heights listed here. Okay? In the second column, we're going to calculate our deviations. If we're going to calculate our deviations, we're going to need to know what our mean is. So to calculate our mean, we need to know the number of things that we have in this list. So 1, 2, 3, 4, 5, 6, 2, 4, 6, 7. That's better counting. And we need to know what all of these things add up to. So basically the sum of all of those x values? Well, we can just add all these things up, 183 plus 165 plus 148 plus 146 plus 181 plus 178 plus 154. Adding that in my head gives me 1,155. So that is the sum of all of our x values. So our mean is going to be 1,155 divided by 7 gives us 165 centimeters. Is our mean. So in the second column of our table, we want to calculate the deviation of each of these heights from the mean. So we're going to do 183 minus 165 to get 18. Is our first deviation. Then 165 minus 165 gives us a deviation of 0. And we can keep doing this. Negative 17, negative 19, 16, 13, negative 11. Okay. Now, if we added up all of these deviations, what would we get? Well, we would get 0. So that's why we are squaring them in our next column here. So we take each of our deviations and we square them. We get 324, 0, 289, 361, 256, 169, and 121. And if we're going to calculate our standard deviation, we know that what we want is the sum of all of our deviations squared divided by n, and then we take the square root. So we add up all of these numbers. So 324, 289, 361, 256, 169, 121, total up to 520. So our standard deviation is going to be, 1,520 divided by 7, and then we take the square root. And we get 14.7 centimeters. So we've done all of that work. Let's go ahead and compare our two data sets here. Our ravens had an average height of 165 centimeters, a standard deviation of 2.1 centimeters. Our falcons have an average height of 165 centimeters with a standard deviation of 14.7 centimeters. So which team is taller? Well, neither team is taller because they both have the same average height. So teams have same average height. Okay. Which team's heights are more variable? Well, it's the falcons. They have a larger standard deviation for their heights, so that means that their height values are more spread out. So we can say that the falcons have a greater range of heights. Let's say a greater variety of heights. Okay. So does either team have a height advantage? What do you think? You can't answer this question just based on the mean and the standard deviation. You have to kind of know how height is an advantage or a disadvantage in the sport of basketball. So we're assuming some knowledge here that is outside the scope of the question. what do you think in basketball? Is it better to have everybody on your team about the same height, or is it better to have some tall people, some short people? What do you think, Cal? Yeah, usually that's the way it works. So we could say something like, the Falcons have an advantage, and I put advantage in quotation marks there because it's not that the Falcons are taller because they have the same mean height, it's just that they have a bunch of different height. So let's just say in basketball, it's better to have, it is better to have both short players, those are your guards, and tall players. That's like your center, your power forward, and so on and so on.